Please pause the video to read the problem statement. Number 1. We need to set up the null and alternative hypothesis. Since the test is about a percentage, this is a z-test for proportion. And since we're testing if the percentage exceeds 20%, then the alternative hypothesis will be p greater than 0.20. In essence, this is a one-tailed test, particularly a right-tailed test. The null hypothesis will thus be p equal 0.20 or p less or equal to 0.20 depending on the convention used. To calculate the test statistic, we use the z formula shown here. P hat is the sample proportion, computed by taking the number of successes x and dividing by the sample size n. The sample size n here is 190, and the number of successes x is 50. Therefore, the sample proportion is 50 over 190, which gives 0.2632. Next, we substitute the values in the z formula. Note that the p is taken from the null hypothesis here. This computes to 0.0623 divided by 0.0290, which gives 2.18 rounded to 2 decimal places. That is, the test statistic is 2.18. Since this is a right-tailed test, the p-value of the test will be in the area in the right tail of the test statistic under the normal curve. We can obtain this area using software or by looking up the value of the test statistic in the less than z table. For 2.18, we look up 2.1 under 0.08, which gives an area of 0.9854. That is, the area below 2.18 under the curve is 0.9854. To obtain the p-value, we subtract this less than area from 1 to obtain 0.0416. Finally, we determine if the economist's concern is justifiable at alpha equals 0.05. The rejection rule stipulates that we reject the null hypothesis if the p-value is less than the specified alpha. Since a p-value of 0.0416 is less than an alpha of 0.05, we reject the null hypothesis in favor of the alternative hypothesis. We therefore have enough evidence to conclude that the percentage of millennials who will dip into their retirement accounts to fund a home now exceeds 20%. We can thus conclude that the economist concerned is justifiable at alpha equals 0.05. And that's it. Thanks for watching.